But does the bacteria can grow all the time? No, not really. They're going to reach a stage which is relatively flat. This is called the stationary phase. Now, why they will have a stationary phase? They will grow, they need to use nutrients from the environments or from the media. At the same time, they will generate metabolic trash, we call it. Let's say some acid, let's say some hydrogen peroxide, or those type of the trash thing. Those will hurt by themselves. So the metabolic trash and nutrients at one stage will be balanced. So they stay. The number will stay. That's called the stationary phase. But at the end of the day, can they stay there, grow forever? Of course not. Because your nutrients has been used in the environment. You more and more metabolic trash, which means toxins generate. They start to die. This is the last one, we call it the death phase. Okay, it's very interesting. That's a fourth stage. You got lag phase preparation, log phase grow dramatically, the doubling time usually, stationary phase. Their number is pretty stable, as then they start to decline, it's a death phase. Now I want to introduce you several concepts. We often see in the textbook, or even in some of the literature, they say, I'm going to kill bacteria. Your bacteria is killed. Curing bacteria, kill bacteria. And we have a terminology for cure, we say it's a cycle. What this means, which means the bacteria doesn't even go to the log phase, they go this way. That's what we call it a silo equals curing bacteria. But most of the time, we say it is inhibit bacteria. What this means? Inhibit bacteria, we should say inhibit bacteria growth. Which means the bacteria is still there, but it did not grow in the number. So if we reacted here, what it gonna looks like? Which means you add something in the food products or in the environment, the lag phase will be extended. But at the end of, it's still going to grow. May not grow that dramatically. It's maybe like this. This is called static, which means inhibit. This is a function. If you buy a hot dog, okay, a hot dog there, very cheaper. Sometimes $4 for a whole bag. If you look at the label, you see those ingredients said sodium diacetate, potassium lactate. What are those? Those are antimicrobials. Do they think they're going to cure everything? Of course not. And we did it in the lab. The Listeria monocytogenes could grow there even. But what's the function for them? They will inhibit the bacteria to grow. And do not let them to passing the threshold will cause toxin. So every bag of these hot dogs, there is a relatively shelf lifetime. It's not going to be there forever. They have to throw them away after a certain time. That's called inhibit. It's only going to extend the lag phase, but later on it's still going to grow. So it's very interesting when we use this curve to talk about the bacterial growth. Okay, it's very, very very interesting when we talk about that. Now, with this curve, we also want to mention several things. So how are we going to storage bacteria then? This is kind of a very tricky question. Okay. I have a broth, tropic soil broth, or nutrient broth, which means lots of nutrition there. We'll mention the nutrition real quick, okay, next week. So the bacteria grow. Very grow turbidity. 24-hour, 37 degrees Celsius. If it's E. coli, it will from 1 cell to 10 to the power 8 cells per ml. Okay, how are we going to storage it? I want the bacteria to be there. Lots of people say, we just left this one on the bench. Or we just keep it at 37. What happened? It will die. Usually, 37 degrees Celsius after 48 hours, it will die because stationary phase, death phase. Okay, some people are saying very smart. How about let's put that refrigerator 4 degrees Celsius. Once they go to the stationary phase, you move to 4 degrees Celsius, it will be stable about 3 to 4 weeks. Not really in a solution. The solution may be a week. Could be as long as 3 to 4 weeks. If I want to permanently storage it, how are we going to do it? I can't do like that. I need to add glycerol and the freezing at minus 20 degrees Celsius. And we will mention glycerol is cryoprotectant. Protect the bacteria does not form in crystal during the freezing environment because the crystal going to kill them. That's not good. So freezing the function is at minus 20 degrees Celsius. We will stop the biochemistry reaction. So this metabolic trash is not generated. So this is a way where we're going to storage a bacteria. So if we run this curve, you know, you cannot just put a bacteria in a tube, in a broth for about like 3 weeks. And then finally you're going to say, okay, let's go ahead to take the bacteria out. It will be dead. Another way we could also mention in the lab, if we do it temporary, what we do, we streak it on agar plates. We have those colonies there. These plates could be at 4 degrees Celsius for 3 to 4 weeks. But no longer than that, otherwise it will be done. So this is some tricky things for you to how to storage a bacteria. It's very interesting. Lots of people doesn't know. They just grow bacteria, put it in the room temperature, then they took from the broth, does not mean they're going to survive. 1 week later, they're going to start to die. On the plates, some people just put there for a week, for months, it's going to die because the curve is there. Without glycerol, due to freezing environments, it's not going to survive very well. Okay. Next we want to mention is that the factors affect microorganisms to grow. Majority of them we want to talk about is next class, but I want just to do an overview here. Factors is usually the environmental factors, including the pH. We know pH, measuring the acid. Including the temperature. Some bacteria like lower temperature, some bacteria like medium temperature, some of them like very hot temperature. Then we want to talk about the water activity. This is a very tricky concept. Water activity does not mean amount of the water. Amount of the water is called moisture amount. Water activity basically means available of the water for bacteria to grow. But the concept is tricky. Next is oxygen concentration. This is the one. When we talk about some bacteria must use oxygen to grow, we call it aerobic. Some of the bacteria can grow with or without oxygen, we call it facultative. But there is some of the bacteria, let's say Clostridium, they cannot grow even with any oxygen. The oxygen will let them die. So these 4 factors is very, very interesting to talk. There's a lot of story behind that, and we will talk about this on Thursday. It's especially the water activity. It's very, very tricky. Little bit of physics story behind it, so we will gonna be explain to you. Okay, little bit of chemistry behind that even. Okay, so we will be end up here. Let's just get to know you, because it's been about 4 classes. I just wanted to know